Hello everyone, let's take a look at our next problem. Find the least positive integer n such that no matter how 10 to the n is expressed as the product of any two positive integers, at least one of these two integers contains the digit 0. Find the least positive integer n. So we're looking for the smallest power of 10 such that if you factor that number, at least one of the two factors contains the digit 0. So I don't really know exactly where to start. My first instinct is to play around a little bit. Obviously the number 10 itself, 5 times 2, neither of those contain a 0. If we have something like, 100 is equal to 10 times 10, but it's also equal to 20 times 5. Okay, so there's a 0 there, but it's also equal to 25 times 4. And so we do have one way of writing 100 as a product of two numbers that don't have a 0. What about 1000? Well, this is 250 times 4, so that there's a 0 there. Maybe the key here, maybe what we should do is we should write, okay, so 10 to the n is equal to 2 to the n times 5 to the n, right? So all right, okay, and now if we want to write 10 to the n as a product of two numbers, we basically have to take there have to be at least n factors of 2 and n factors of 5 in the pair. Now, if I write this, for example, as 2 to the power of n minus 1 times 2 times 5 to the n, this will have a 0 in it, right? Because this is equal to 2 to the n minus 1 times 5 to the n minus 1 times 10. Right? And if the reason I'm writing it this way is I'm thinking of these terms in parentheses as being the two positive integers that multiply to 10 to the n. So this number has a 0 in it because it's a multiple of 10. And so if we are to write 10 to the n as a product of two numbers that do not have a 0, it has to be written as 2 to the n times 5 to the n, right? Like the actual decomposition we need such that there are no zeros is 2 to the n times 5 to the n. So the way I want to answer this question then is look for the smallest value of n such that either 2 to the n or 5 to the n has a 0 in it for all values of the exponent greater than or equal to n. Okay, so like we're looking for and is there an easy way to figure that out without explicitly writing out the powers of 2 and 5? Oh, I was a little bit confused. We don't need the least positive integer n such that this property is satisfied for 10 to the n and all higher powers. That may not even be true. I was wondering in the back of my mind whether that would be true, and I didn't think so. Basically, what I'm looking for here, I need to finish this table of numbers here and find the first row where both numbers contain the digit 0. Right? Because any pairing, like I argued up here, any pairing other than this one of the two numbers is a multiple of 10. So we're looking for the first row where both numbers have a 0 in it. Yeah, okay. Well, I'm just going to continue going down my powers of 5 here, and I'm hoping in one of these three that we get something with a 0 in it. So I've got here that the 12th row of this table is the first occurrence where both of these numbers have the digit 0. This is a little bit more brute force, a little bit more of a brute force approach than there might exist. I don't know if there's a more elegant way of doing this. And I'm pretty sure this is correct unless I've made some mistakes in calculating these powers of 2 and powers of 5. If I find an error or if I have more comments, I'll put it in the description below. Otherwise, thanks for watching. Hi, made a really stupid mistake. I don't know where my brain is at the moment and why I'm not thinking straight here. Misinterpreted what I was trying to do with the question. We don't need the first row where both numbers have a 0. We just need the first row where there is a 0, which is this one right here. So this corresponds to n equal 8. And in fact, this row here would not, no, I suppose it would satisfy the property that both of the numbers in the product, at least one of them has to have a 0. But we only need at least one of the two numbers to have a 0, not both of them. So no matter how you write 10 to the 8 as a product of two integers, at least one of the numbers will have a 0. If you don't have the grouping like this, then one of the numbers will have 0 in the last digit because it'll be a multiple of 10. And if you do write the grouping like this, then 5 to the power of 8 here has a 0 in it. And so that's n equals 8 is the smallest value where this product has to have a 0 in it somewhere. Don't know what I was thinking, why I misinterpreted such a simple question. But anyway, that's the answer. Thanks for watching.